Right, girls, welcome back. We're going to start and take a look at the last part of this chapter, which is called transformations of graphs. So we looked at translations and transformations at the beginning, the very beginning of second year, because it was the end of your first year course. So we looked at transformations and translations, and that's where you're moving something. I noticed I've spelled the word wrong. Don't know why I'm correcting that now, because I'm pretty sure you know I can't spell. Anyway, transformations of graphs. A transformation or a translation is where you move a graph from where it was to somewhere else. Okay, and this is particularly where we're looking at the transformation where I'm moving a quadratic equation. Okay, so this is the general formula for a quadratic equation, and again we remind ourselves of what the two pieces are that we already know. Okay, we already know that this is where it crosses the y-axis. So we already know that that's called our y-intercept, where I cross the y-axis. Okay, and this one, the A, already told me about the shape of the graph. So if you had a positive, you had a U-shaped, and if you had a negative, you had a frowny face shaped. Okay, this is now talking, and it's going to use these ones again, but it's going to ask you to go a step further and take a look at them. So I'm going to write them first and then I'll explain them. So the first one, what happens when I change this A? So what do I mean? Well, if I had a formula, we'd say 1x squared, and then I changed it to 2x squared, or I changed it to 3x squared, or to 4x squared. What does that do to the graph? Okay, so it could change the shape. So it could change the shape. How could it change the shape? Well, if it was a positive and I changed it to a negative, I changed the shape of the graph. It'd be completely different. Okay, but normally, if I leave them all as positives, it'll widen. And that's actually, to be honest, actually, I don't really like that word. I'm gonna change that word. I'm gonna use a word we're definitely not supposed to use, because it'll be easier for us to remember it. I'll make it fatter, or I can make it skinnier. And they're words I know I'm not supposed to use, so you'll remember them. Okay, so I'm talking about making something fatter or skinnier. So if I change that number, I will create a graph that is either fatter or skinnier. So what do I mean? Well, let's take a look at a sample graph here. Okay, and I'll do this one all in green. Let's say I have a graph and this is what it looks like. Okay, and the formula for this graph, if I looked at it, was x squared plus 2x minus 4. Okay, what does the minus 4 tell me? It tells me it crosses here at minus 4, because it tells me the y-intercept. The 1 in front of this tells me that it is a U-shaped, and that's what I know so far. Okay, and let's say I change that graph from 1x squared and I change it to 2x squared, but I leave everything else the same, 2x minus 4. What happens to the graph? Well, the graph gets skinnier. So it becomes the black line. It's the same shape. It crosses at the same point because I didn't change the minus 4. But it gets skinnier, brought in a little bit on itself. If I changed it to 3x squared plus 2x minus 4, what would happen to the graph? I should have done that in a different pen. Someday I'm going to be really good at being organised, and that it's just not going to happen this week, I don't think. Okay, I'll get even narrower. Same shape, crosses the same place, but skinnier. So that's what I mean by skinnier. The graph started here, was nice and fat, went on some sort of fancy diet, and it moved in, and it moved in, and it got skinnier. Okay. Now, if I want the graph to get fatter, the number has to go down. So where it was 1x squared, I'd change it from 1x squared to, we'd say, a half x squared. But I'd leave everything else the same, plus 2x minus 4. Okay, and I'll make this one orange. So the original graph was here. The new graph now is just going to be a fatter graph. Like the orange line there. Okay, because that number went down. So if that number stays a positive, the shape stays the same. And what you end up is if the number gets bigger, it gets narrower and narrower. And if the number gets smaller, it gets fatter and fatter. So what's smaller than a half, but still a positive? I could go a third or a quarter. Okay, and the graph would just loop around and get loopier and loopier and fatter and fatter. Okay, so that's what the impact that number has, the A has on the graph. All right, the next number then we're going to take a look at is what happens if I change the C. So again, I'm ax squared plus bx plus c. We already know that c tells me where it crosses the y, it's called the y-intercept, where it crosses the y-axis. So what happens to a graph if I change this number? So again, if I start with ax squared, we'd say, 2x squared plus 2x plus 1. Okay, so what does that mean? Well, it's 2x squared, so it's going to be fairly narrow, and it goes through 1. So this would be what that graph looks like. Okay, well, it's crossing at number 1. Okay, if I change it now to stay as 2x squared plus 2x, but I change this number to minus 4, what happens? All that happens is that this graph stays the same shape, but it comes down now and crosses at minus 4 instead. But it keeps the same width and the same shape. Okay, if I see if I have another colour here. Okay, what happens if I go 2x squared plus 2x plus 3? So it now means it's going to cross at 3, but it's going to keep the same shape. So what does that C do when you change it? So when you change it, you move the graph. How would we describe it? I would describe that as, now in the book they describe it as vertical movement, and they're right, like you're going this way, but that's hard to remember. So I always say it moves the graph up and down. So it just makes the graph go up and down. So it started here, I can go up or I can go down. So if that number goes from a +1 to a -4, it's going down because the number got smaller. It's going from -4 to 3, it's going up because the number got bigger. Okay, so this number changes how fat or skinny it is. This number moves it up and down, and that only leaves you with B. So what other way could I move this graph? And once you think about it, I've done fatter and skinnier, I've done move it up and down. So the only option for this one is move it left and right. And that's what that letter does. Okay, so what the last letter does, ax squared plus bx plus c, is this number moves a graph. And they in your book say horizontally, and they're right, this way, yeah? It moves a graph left and right, because I just think that's easier to remember. That's more our normal language. We don't normally talk about things being any other which way. We always talk about them left and right. I think it just makes a little bit more sense. So what does that mean? Well, let's see. If I had a graph that was here and I changed that number. So let's say this number was 2x squared plus 3x plus, no, that should be a minus because it's crossing over there, -1. Okay. And I'm going to keep the 2x squared and the -1 the same, but I'm going to change it from +3 to -3x. What would happen to the graph? The graph would move over from here 3 places, 1, 2, 3, and here 1, 2, 3, but the shape would stay the same, and that would be your graph. Obviously it's supposed to go through that point. Okay. If I changed it to +6, I'd move 3 places this way. Okay, so if I changed it to 2x squared plus 6x minus 1, the graph would move 3 places from where it originally was, 1, 2, 3, 1, 2, 3, keeps the same shape, the same width, but it moves to the right. Okay, so you can move it right or left. With the majority that I've seen in terms of these questions, girls, and you'll see them now in your textbook in a moment, they're only asking you to tell them what type of transformation it is. Okay, so it's, some of them are going to ask you to draw and then tell them what's happening, which I don't know how useful that necessarily is, but no, I suppose we do one or two, okay? We're not going to do a huge amount because then you're just going to get to the point where you're a little bit bored of them. So let's go with page 427, and you're going to do, we'd say, question 3A, B and C, and you're going to do them all on the one graph, and then we'll do 5A, B and C, and that'll do you. And what that does is you're going to be asked to draw 3 graphs in the one place, and you're going to see the difference when you change the A's. This one you're going to see the difference when you change the C's. And then the other one, that's the way I've always learned it. So if it hasn't moved up or down, got skinnier or fatter, then you're changing the middle number. Remember when we were doing the graphs, girls, we talked about the middle child, the middle number gets forgotten, and it does get forgotten. And I recommend you forget it. You learn the other two. You learn what happens when you change your A, gets fatter or skinnier. You learn what happens to your C, moves up or down. The only other option for the graph, if you wanted to move it, is left to right, that you slide it back and forth. You don't have any other options. Okay, so if you learn A well and you learn C well, then you don't have anything to learn about B, because B is the one that you hadn't seen before. All right, okay, so I'm going to pop this up, girls. I'm going to ask you to do page 427, 3ABC, 5ABC. It looks like a lot, but it's actually quite short. And that brings us to the end of that chapter, girls. And from then, we're going to move on. We want to do manipulation of formula and exponential graphs. So I'll give graphs a little break. We'll do manipulation of formula, and then we'll take a look. Manipulation of formula, which is very short, and you will actually be very good at it because it's based on algebra, and it's, even though I know some of you don't think you have algebra skills, you do have very good algebra skills. So we'll take a look at that and we'll go on to exponential functions. So I'd hope maybe we get manipulation of formula done this week coming into next week, and then we'll do exponential formulas the following week. And then there's a bit of transformation geometry, but it's very much what we did at the beginning of second year. There's nothing extra in it, but we will take a little whiz through it and revise it, because we did that at the very beginning of second year, which most of you probably don't even remember. You were only getting settled up with me and settled in with me, and we were still fighting, if you remember. We were making sure homework was done and stuff. I wasn't being very friendly. So I'll go back through it just to make sure that now that you're